All right, so it's now lunchtime. What better time to make another JNCIE-SP video? Last video, we looked into BGP neighborship authentication, and we looked into more about how routes are added or removed from the BGP protocol. So this video, we're going to be looking back into BGP neighborship authentication, but this time we're going to be trying to get a keychain to be successful instead of just straight MD5 password applied to the BGP group. So let's open up router 1 and take a look at how that works. Get the Wireshark capture going. So you can see I've got the configuration set up from last video with the authentication key. So I'll need to remove that. And we'll see a 4-way disconnect in Wireshark when I remove that. And then when I remove it from the other side, we'll see a 3-way handshake because it will reestablish without authentication. So just need to copy this. Let's see here, configure private. Oops, edit protocols BGP, group EXT, show pipe display set relative, delete authentication key, commit. So now we'll see the 4-way disconnect, FINAC ACK, very good. So we might see some SINs trying to reestablish that, but of course it's not going to be successful because only one side has that authentication configured. So here's the SINs coming, trying to reestablish that. We can see if it's the one we just edited or if it's the other one based on the TCP options, because the one we just edited, of course, is not going to have an option for authentication. So this one still has the authentication. So .1, of course, is coming from R0, but this one you can see there's no authentication. So .2, anything from .2 is not going to have that TCP option that includes authentication. But if I click on a packet for .1, there it is. So let's go on to .2.1 here, 172.16.2.1, and let's remove the MD5 signature. Okay, so now we'll see a SYN-SYNAC ACK, and that will show that it is now successfully authenticating. And we'll see the MD5 signature showing up whether it was sourced from .1 or .2. Or sorry, we'll actually see the absence of this, whether it was sourced from .1 or .2. As long as the capture is still running. And it looks like the capture is not still running, so we missed that 3-way handshake. But we can, of course, just stop it and start it again. And then if we really want to see the 3-way handshake again, we can always restart the neighborship. So we'll see a four-way disconnect because it did actually go ahead and, well, we probably won't see a four-way disconnect because I shut down the interface, so it's not going to be able to actually reply to that. It won't be able to do the full FINAC-AC, or sorry, FINAC-AC. SYN would be for the handshake, the initial three-way handshake. Yep, so let's go ahead and bring that up and we'll see the handshake, and then let's build a keychain and see if we can set up successful BGP neighborship relationship using a keychain instead of direct authentication in the BGP group. So I'm going to roll back this, and we'll see that port come up, and we'll see a three-way handshake. We can see they're all coming from .2. So here's our three-way handshake. And you can see it's interesting. We've actually got one three-way handshake sourcing from .1, SYN, SYNAC-AC, and then a BGP open message afterwards. And each of these messages are going to have an extra TCP option. Sorry, they're no longer going to have that extra TCP option for authentication because that was removed. And then even the BGP open message after that still has those TCP options, but not one for authentication. But you can see here's one three-way handshake for sourcing from .1, and we've actually got a second three-way handshake here, SYN, SYNAC-AC. Looks like this is sourcing from .1 as well, so maybe it failed on the first one for some reason. We can follow the TCP stream on this first one and just only look at that one. Try to get a better sense for why it did another TCP three-way handshake from .1. We can see there are some unusual messages. There's a FINAC-AC. So FIN, we know that the four-way disconnect is FINAC-AC. So it looks like there are messages that are kind of similar to that. Really not sure what they're all about. We've got a TCP out of order message, so lots of kind of unexpected behavior happening when you filter out based on this first three-way handshake. So let's take a look at the second three-way handshake and see if that behavior is more what is expected. So the second three-way handshake, SYNAC-AC right here. Let's follow that one. We can see it's the same source and destination. And yeah, here we go. So this is more what we would expect to see. We've got the open message, and then we've got keep alive following after that. So that'd be something interesting to dive into. Just why did the first three-way handshake fail, and it actually had to go and do a second one? So, I mean, it's all right there to dig into. Looks like there was an out of order TCP packet, so it just kind of gave up on that one and did another one, but looks like the other one is all good to go. So no issues now. So let's set up that keychain. Okay, and I'll use the documentation for a guide, but I might need to stray from it. So edit security, authentication, keychains, keychain, and we'll call it just BGP auth Same thing they're using there. Now we're going to just have one key, keep it easier. Set key 0, secret. We'll say secret key. And then we'll set the start time. And it looks like it does need to be, so we'll do run show system uptime. So year, month, day, hour, minute. So the start time is going to be start dash time, and it's going to be 2020, April, and today is the 7th. Now a dot, and then the hour, which is, according to this clock here, 15. And then the minute, well, let's just make it 16 and maybe move kind of quickly and see if I can get it up by that time. So right now it's 59. So let me do a run show system uptime. And it's at 58. So let's give ourselves a little bit more time. Start time 2020 04 07 dot, and now let's go all the way to 16, and let's give ourselves plenty of time, so to 03. There we go. And now we'll commit that. Oops. Or, well, before we commit it, let's go ahead and apply it. Okay, hopefully this commits, and then we'll see that four-way disconnect. And the four-way disconnect is going to be in this filter, because this is the filter that connected it. So we can just keep filtering this, and we'll see the four-way disconnect show up. Although, of course, it's always a possibility that it is no longer capturing, but of course we can test that by sending some ICMPs through. Yep, and it's no longer capturing, but that commit went through. So let's go ahead and set up the other side so we don't miss that window we set up. And it's just going to be the same configuration. There we go. All right, so commit that. And now do a show system uptime, type refresh 1. And let's just look at the current time, type match current time. And now we'll see, yep, so it's getting close to that 03. So let's make sure we've got a fresh capture ready to go when it hits that 03. So we're getting close to 02, not quite at 03 yet. We can see, let's take a look at the BGP summary on this side. Should be inactive. And sure enough, it's inactive. So coming up on 02. You see all we've got is some ARP traffic now. So it looks like it's not even attempting to form that neighborship now that that authentication key isn't active. That's interesting. I would have expected there to be some sins going on. different from what I expect. Coming up on 02, and then we just got 1 minute to go. So yeah, not much to look at until that minute comes up. I guess we can verify that the capture is live in that minute. So we'll go ahead and do that, although it is getting pretty close. Oh, so it's definitely live. So let's put that other one back up, clear the filter, and we're at 30 seconds. So 30 seconds isn't long. It's enough time to wash your hands if you haven't done that yet. Make sure you're doing that every day. That's important, especially if you go out. So 5 seconds. All right, and now hopefully we will see this switch. Yep, there we go. Now it's an open sent. It's not gonna see open confirmed, but we can see a window established. And unfortunately, it looks like the Wireshark capture just randomly flaked out again. It does that. We know just based on what happened here that it went through, and we know what those packets look like. We've already looked at them many times. It's going to have an extra TCP option. It's not going to, I think, be any different. I mean, that's something we can, of course, look at. But as far as I know, it's basically as if you're applying it to the port directly. The only difference is that the password you're applying is now part of a chain of passwords. So like you don't even know yourself necessarily which password is being applied. It's just going through that chain. So it's that extra level security where not only is there a password on there, there's any number of configurable passwords being used, and at any given moment you're not exactly sure which one is on there, so you couldn't even say yourself what the password is, and it's much more secure. It's kind of a form of two-factor authentication in a way. I guess not really, but it's just an interesting thing that's kind of, I guess, not too difficult if you think about it. It's really just a key inside a keychain, and then the advantage of that is you can have multiple keys, and then it will cycle through those keys in accordance to your start times. So start times are specified. They must be unique within the keychain. Oh, that's interesting. So we can see here, and this is probably worth a downvote, start times must be unique within the keychain. So following this documentation as is, of course it's not going to work. These are not unique start times. So you know what? I think that's worth a downvote. So happy birthday to Norman. And I will go and submit that downvote, and I think that'll be the end of the video. Really, keychains aren't that complicated. You just use the question mark and you can see kind of what all of the options are, and then kind of the advantage of a keychain over just a key in the BGP group is that you can cycle through the keys and you can have that extra layer of security. So let's submit that downvote. So it says, start times are specified in the local time zone for a routing device and must be unique within the keychain. But in the step-by-step procedure, step 3, the start times that are given for each key are identical. So that's obviously a very serious issue with this documentation. It's one that prevented this video from just following it completely, but we got some exercise, did some question marking, did kind of looked into it a little deeper, so it's not necessarily the worst thing in the world. And I'll restate that I am very thankful that this documentation exists as it does, but I'm going to do my part to make it better. So I hope you enjoyed the video and stay tuned for the next one.